Hi, I'm John for Proper Printing, and I just came back from holiday, and we were very lucky because if we stayed one more day, then we weren't able to come back. On my holiday I had more than enough time to think about a proper design for this video. It's pretty stupid that I'm looking forward to this video for, since the beginning of the video series of that foldable Ender 3. But just this holiday last week I came up with the design, which hopefully works. Yeah, we are going to make a food printer out of an Ender 3. At least that's the plan. Okay, I got my inspiration from this dude, Jan Smink. Jan Smink is a chef, and almost half a year ago I got a presentation from him about food printing. I thought, how hard can it be? So I decided to make a food printer out of an Ender 3. If I run this video, it uses this syringe over here, and it just pushes the filament or food down this nozzle. This is not very new, but it's cool, and I want that as well. And I want this for my own tool change, so I can add another tool to the list of tools. And I think for 3,900 euros I should be able to make a food printer. So I started designing in the Fusion. As you can see, it fits the tool holder. If I zoom out a bit, then this is the whole thing. And yeah, you can see it's not so much targeted towards hygienic than the other printer. This is purely functional, and it has to look cool. Here on top it should fit the detachable direct drive that I've made, not in my previous video but in the video before that. It's the flexi drive that I've made detachable with the use of this hexagon bit. These gears, these are made out of nylon. I've made a tapered edge on here that makes it a lot easier to print. Yeah, if you use a tapered edge like this and you place that face down, facing towards the bed, and it curls up a bit, or you have elephant's feet, it doesn't care that much for the teeth itself. I'm very happy with the result. It has two of these threaded rods. This is a 2mm threaded rod, and I can just pretend like I have intentionally bought this 2mm threaded rod because of my my calculations, so it fits well with this design and the step value of that E-stepper motor. But truth is that I have bought this threaded rod a while ago while I was working on the dual Z-axis, and some of you can see this one coming. The standard Creality printer have a 8mm pitch, and this has a 2mm pitch. The other rod will go up four times faster than on this side. Yep, I smacked myself in the face a few times and bought the 8mm pitch. Don't make that mistake. This part here is this, and you're not going to believe me if I'm going to say that this is my first try, and for good reason. Because this is not my first try. This is printed out of ABS, and it turned out great. If you are wondering what my secret is about printing these large parts with ABS, just this jacket over here is my secret. Nice. So I can just place a syringe here, and it clicks into place. And the last thing, there must be something to push this down, of course. This pusher, it clamps on the top of this syringe, and on the other side it will snap onto this thread. Just snaps into place. In this way I don't have to rotate it all the way back up. I can just snap it onto there and start printing food. Because if you're hungry, you just want to start printing food. And now I have to find a way to shorten this one, because this is hardened steel. And okay, I've got all the parts here, and I've already added the inserts into this part. Now it's time to mount everything together. What the hell was I thinking? It just puts itself together and does work. I can just clamp this on here. Yeah. Looks a bit like a futuristic vaccine gun. Oh shit! Stay with me, man. Hey! Hey, stay here. Come on, don't die me, man.
Trust me on this. It may hurt, but
I have found this old piano stand so I can reach the electronics. I just have added this ultrasonics board. It's huge, it just fits in here. I just downloaded the Repeater firmware. With their firmware configuration tool, I managed to flash firmware and it seems to be working. Except for the Z-axis, but that's what I'm going to work on right now. Okay, one thing I already have found out. In order for this to work, you must disable that cold extrusion prevention. It was at 170 degrees, but I don't want to turn on this. So I've set that value to 0, so I can just extrude. I have to raise that homing switch. Some of you already know that I've made a tool change with Z-homing in it. This is the reason why. Well, one of the reasons. For now I will just raise that homing switch. Let's see if it extrudes. I have already tested. The motor is connected properly this time, so I will not blow up the stepper. To be sure, I will put this in the middle, because I don't know in which direction it will extrude. Here we go. This can be a bit of a problem. So I'm going to make this run a bit smoother. See if I can wait one moment. And I'm going to fix that firmware that the Z-axis, the steps are correct. So because it's running super slow right now. Yeah. So the sun has started to shine, so I opened up everything. Have to let out the key. Yeah. I have managed to fix that Z-axis. I wasn't the only one with this problem. If you use the Repeater software, then chances are that X and Y work properly, but the Z-axis will go terribly slow. The thing that solved it for me is setting the EEPROM mode to 0. So all axes work, including the Z. Nothing is burning out. The center gear wasn't running smooth, so I've made a bit more clearance and added a bit of lube. Let's just try fill this thing up with food and let's see if which E-step is the best for this. Still, it's cold here. Okay, before I'm going to print anything, I have to design something to print, and I have to make a profile which works with this tool. I'm going to make a pretty difficult design. An extrude of 0.6, just to try. Send this to simplify. Now I have to make a new material, and I'm going to call this pate. Temperature of the heated bed is 0, and of the primary extruder also 0. Good printing. This sets the new E-step value of the nozzle, and I'm just guessing 1900. Save. And I have installed a Repeater server so I can upload the G-code. Let's make some build surface first. This amount is just for testing purposes, and I am a bit skeptical because it is pretty hard to push this out. One important thing is that this color here must be clean, otherwise you put food in there. Turn on the printer. Let's start the G-code. Print. Oh shit. Oh fuck. Okay. Stop. Yeah. I think I have got a little bit of over extrusion. Okay, I've cleaned up this glass plate with dishwasher soap. I have raised the printing speed and I have decreased the E-step value by a lot. Let's try a second time. And I have removed that purging step at the beginning, so it doesn't purge all that material on my printer. A bit of over extrusion still, but this is going to this looks very promising. The E-step value is now half as much, so print. It takes a bit too much force for this axis to purge all this material through that nozzle. I'm thinking, do I have to change that gear ratio? Or okay. I think I have an awesome idea. Well, that idea sucks. I just started modeling, and after I have modeled everything and and I printed it out of nylon, I realized this is so stupid. If you have a planetary gear system on this side, you will reduce the gear on the side of the motor. But the problem isn't at the motor but within the shaft, so the same amount of force is still applied on that shaft. Oh. Okay, I think I'm going to tackle the problem on the other side of the shaft. The tail was pretty difficult to extrude, so I'm going to use Sounds of Mario. Okay. This is not bad. This is not bad at all, but I have to decrease that E-step value. This is good enough for your toast, I think. believe it or not, but this is the last video of the video series of the foldable Ender 3 Pro. I can hear you thinking, why did you make it foldable in the first place? The reason for me to make it foldable is that I wanted to take it on the road and print food somewhere. But due to what's happening in the world right now, that is not going to happen. As you've seen in this video, the flexible shaft isn't strong enough for this tool. It's not a problem of the shaft. This is just not rotating smooth enough. I can't get it smoother, but what I can do is add a gear ratio to it. For now, I've decided to focus on my next project, and that project will be pretty big and challenging. I really hope I can pull that one off. For now, for this series, this is it. I hope you have enjoyed watching this video. If you haven't subscribed already, please consider doing so you don't miss a thing. For now, I'm going to work on the next project, and I'll see you in the next video. Bye!